Alright, so we're going to do some more examples on the area between the curves. So here we want to find this area, but we're not given an a and a b value where we have to evaluate it from. So we have to actually solve for those points. So we need two x values that show where this and this, where they intersect. And to do that, we just set the two equations equal to one another. So x equals 2 minus x squared. Pull them all over to one side. We're going to have x squared plus x minus 2 equals 0. If we factor this, x plus 2, x minus 1, and x equals negative 2 and positive 1. So this is x equals negative 2. This is x equals positive 1. So when we set up this integral, we are going to do the top curve divided or minus the bottom curve. So the area is going to equal, we now know it's from negative 2 to 1, which we didn't know until we did the integral there. From negative 2 to 1 of f of x, which is 2 minus x squared, minus g of x, which is just x. And once you get this part set up, I don't think you guys have that much of an issue as far as doing the actual math here, but the setup might be a little bit challenging. Anyhow, let's see. This is going to be 2x minus 1/3 x cubed minus 1/2 x squared, evaluated from negative 2 to 1. All right, now we just plug in our values. 2 minus 1/3 minus 1/2 minus negative 2 times 2 is negative 4. Oops. Negative 2 cubed is negative 8 times negative 1/3 is positive 8/3. And negative 2 squared is positive 4 times negative 1/2 is negative 2. All right, we do that math. The first one is 2 minus 1/3 minus 1/2 is 7/6 minus negative 4, negative 2 is negative 6, and negative 6 is going to be negative 18 over 3 plus 8 over 3 is going to be negative 10 over 3. Anyhow, that becomes a plus. 10/3 is the same as 20 over 6 plus 7/6. Your area is 27 over 6, or 9/2. Okay. Alrighty. Well, I've got two more for you, so let's check them out. Here's another. This one's a little bit different. We have a sine curve and a cosine curve. So obviously the two curves are infinite and they're periodic. So this area, this region that you see here is actually repeating. So we just want the area of one of these regions. If you see, granted my graph isn't perfect, but this region, they're all identical. So we have to see when they're equal. Well, when is sine of x equal to cosine x? That occurs at, let's see, pi over 4. They're equal. And at 5 pi over 4. That's when they are equal. Now in this region, it's a little bit tricky, but you have to kind of follow it back. This curve is the sine x curve, and this is the cosine x curve. The only reason it's important to identify them, because in this point, sine x is above cosine x, so you have to take this one minus that one. Over here, they would actually switch places. So if we chose to use this region, we would have to do cosine minus sine. So you have to just be aware of that when you're setting these up. All right, now we can actually do the setup, and we're going to get area equal to from pi over 4 to 5 pi over 4, sine x minus cosine x dx. let's see. This is good. The integral of sine x is negative cosine x. The integral of negative cosine x is negative sine x. And we're evaluating that from pi over 4 to 5 pi over 4. All right. Very good. Oh, no, I'm sorry. I was just checking something. All right. Sorry about that little distraction. All right, so now we just plug in values. So the cosine of 5 pi over 4, well, negative cosine of 5 pi over 4. Let's see. Cosine is your x value, so that's negative square root 2 over 2 minus sine x is also negative square root 2 over 2. All right. Oops, that was pi over 4. Oh no, that was 5 pi over 4. We're good. Minus, when we plug in pi over 4, negative square root 2 over 2 minus square root 2 over 2. All right, good. All right, this becomes a plus and a plus, so that's going to be 2, and that's a plus and a plus, so that's 2 square root 2's over 2, so area is equal to 2 square root 2's over 2, clearly those both cancel, minus 2 square root 2, negative 2 square root 2 over 2, once again, so the double negative, so those two cancel, so we have square root 2 minus negative square root 2, which is going to be end up being square root 2 plus square root 2, which is 2 square roots of 2. You could do all that math yourself. Anyhow, that's what we get for this. All right, one more, and this one's definitely different. So I have two functions here. The issue with these two functions is they intersect 3 times. So if I want to find the area of the region between the curves, I want to find this area and this area, and I'm actually want to add them together. The issue is I can't just do the integral from this x value to this x value, because here f of x is above g of x, but in this region g of x is above f of x. So we actually have to do them in 2 separate parts and add them together in the end, because we have to reverse what's happening with them. So anyhow, we have to find the points of intersection just like we did before, and let's see. So we would just set them equal to one another. I'll do that up here. 3x cubed minus x squared minus 10x equals negative x squared plus 2x. The negative x squares are going to cancel. Can you see that? And I'm going to pull the 2x over here, and it's going to become a negative 2x. So 3x cubed minus 12x equals 0. I could do some factoring. I'm going to take out 3x squared, or excuse me, just 3x, leaving behind x squared minus 4. All right, so when we go ahead and factor that and solve it, 3x equals 0, so x equals 0. X squared minus 4 equals 0, add the 4, square root it, and then we get plus or minus 2. So this is negative 2. This, of course, is 0. And this is positive 2. So when we set this up, it's not too difficult, you just have to be careful. So the area is equal to, from negative 2 to 0, it's this curve minus this curve. This curve is f of x, and then this curve is g of x. So 3x cubed minus x squared minus 10x minus negative x squared plus 2x dx. And then to that we're actually going to add the other part, plus, now from 0 to positive 2, now we have g of x minus f of x. So we're going to have negative x squared plus 2x minus 3x cubed minus x squared minus 10x dx. So it's not any more difficult math-wise, but there's just a lot more steps. So of course, in any case, when there's more steps, more places for mistakes. All right, let's see. I'm going to write this out nice and neat. From -2 to 0, 3x cubed, negative x squared minus negative x squared, that cancels. Negative 10x minus 2x is minus 12x dx, and then plus from 0 to +2, negative 3x cubed plus 12x dx. So you can see they're actually very much similar, but because we subtracted in the opposite order, they just kind of switched what they were. All right, now we just have to go through and solve. Let's do the integrals. I'm going to add 1, which is going to make that 4, and get the reciprocal, so 3/4 x to the 4th minus 6x squared from -2 to 0 plus negative 3/4 x to the 4th plus 6x squared from 0 to 2. Plug in our values. Let's see. I'm going to plug in 0 first, and that's going to be 0 and 0, minus, I'm going to plug in -2. -2 to the 4th is 16 positive. 16 times 3/4 is 12. -2 squared is +4 times -6 is going to be -24. Plus this one, I'm going to plug in 2. 2 to the 4th is 16 times -3/4 is -12. 2 squared is 4 times 6 is 24. Minus, plug in 0, and we get 0. All right, great. Let's see. Negative, the 0 just kind of goes away, minus 12 minus 24, so minus -12 plus +12, and the 0 just goes away again, and then of course the answer would be 24 in this case. So the area in between those two curves is 24. So if you ever have a case, the only difference between this one, if you ever have a case where there's more than one point of intersection, well, more than two, excuse me, you have to do them in separate sections. So I had to do this one in 2 sections. All right, so the problems I would like you to try are on page 418. Let me slide down. So page 418. 1, 3, and 5. You just have to set them up. Don't solve anything. Just write it out how you would solve it. And then these 3 you're going to solve, and that would be 17, 19, and 23. Try out those 6 and then send them in to me.